Okay. Good evening, everyone. I'm Sneka. I work as a software engineer at Schneider Electric. So here I'm excited to take you all through the AI-driven tender processing solution. Before we dive into the solution, let's first try to understand the key challenges faced by our tender engineers. So first, if you see the variability in SLD formats, so the single line diagrams, they come in multiple formats with the different symbols, layouts, and file types, making this standardization a major challenge. Next, the complex technical specifications. In general, our tender engineers, they deal with highly technical documents, say of 2,000 pages or 3,000 pages that follow different compliance standards, making it difficult for them to ensure accuracy in every bid they go. And the final thing is a time sensitive thing. Generally, bidding processes, they come with very tight deadlines. So in that case, our tender engineers, they have to extract and analyze the data quickly so that this process will become overwhelming when done manually, right? So what if the tender engineers are receiving a PDF of 2,000 or 3,000 pages? How will they actually go through these pages and the information and extract everything in less than an hour? So considering all these solution challenges, we need a AI-driven solution that actually automates and accelerates the tendering processes while ensuring the accuracy as well. So to tackle all these challenges, we have leveraged a combination of AI, automation, and cloud-based processing. And there we have the core technologies used here like OCR, where we use AWS text extract and recognition. So this text extract is used to detect the text from PDF, scan documents, handwritten copies, and tables. And then the recognition, to, when we upload the images, we will get the OCR out of it, where it detects the dominant colors in it, then the symbols and text in it. Next, we use AWS Bedrock LLM that uses Claude 3.5 Sonnet model. So this is one of the most intelligent model that has the highest level of intelligence and capability. And here we have the input tokens of like 200K and output of 8,192, which is very much needed for our complex solution. And then we have OpenCV to enhance the quality of image. So what if whenever we get the SLD images, we will get it assigned some bounding boxes. So we have to crop those bounding boxes to get the image out of it. What if that image bounding box is very small? In that case, we should make sure that the quality of the image is not actually broken. And then we use Amazon S3 to store the uploaded documents in each processes we done. So whatever the documents required, we will store it in Amazon S3, and then we use SQS service to process the documents in the order we actually receive it. And we also use step function and Lambda to orchestrate the multiple steps. So once this executes, we will get to know like what step has been performed and what data has been passed between the steps. Then I will take you all to the solution architecture. So our workflow begins with the tender engineers, ETO tender engineers. They are initiating a tender request by uploading the documents given by the customers via the LEAP application, which we call the date platform. And once they upload it, we store all these documents to our Amazon S3, where we ensure encryption and cross-account S3 replication from their S3 account to our account. Once after that, we have this SQS, which plays a key role over here. So this will process the documents in the order we receive it from the tender engineers. And then we have a basic data quality check where a lot of things will be done. And after that, we have this SLD and the tender specification documents. SLD is the images, and tender specification documents will have the information about the tenders, like for what they are actually processing the tenders for. So these two things will undergo OCR-based text extraction using the text extract and the recognition. So once after that, we have these ML models and prompt engineering that apply predefined set of rules and criteria to generate the technical offer summary, the final report. So these prompts are actually defined after having multiple analysis and discussions with our subject matter experts to understand what are the options to be considered for which parameter in the Excel sheet, the final Excel sheet they want. So after this, we send this to the API Bedrock endpoint. So we get the LLM response. Once after that, we actually format the LLM response into the desired format requested by the tender engineers. That will be stored into the target S3 bucket. So from there, the ETO engineers, they will take it from the date platform and they will actually manually configure it to the satellite platform. which is a global system for medium voltage equipment configuration and order processing. So by leveraging this automation and AI, we actually transforming this tendering process in a very different way, making it faster, smarter, and even more reliable one. So now I'll take you through the step function design we have implemented. So our step function starts with the Lambda function invocation, which triggers this entire pipeline. Here we have two parallel branches. So the first branch, if you see here, this will be handling the text documents using texttract. And then the second one is for the recognition, the images uploaded. So here in the batch split PDFs, we have whatever the large size PDFs is there, we just split them into smaller chunks. And then it will go through this batch document analysis where the splitted documents are sent to the texttract. So here we have this API called throttle to maintain the rate limits, and also we have a wait time of 20 seconds to make sure this process is completed before we move forward to the next step. And we have this batch process extract output, which checks the stage of the batch document analysis, whether it is completed or not. If the job is not completed, it waits. If it is completed, we have the information from the extract. And then we have recognition, where whatever the images we upload, we will get the text and symbols extracted out of it. So once we get information from these two separate branches, we just consolidate them into this concatenate results. So along with the concatenate results, the prompts which we have defined for different sheets, which are SWB, panel, and CD, you see down. SWB is switchboard, panel, and then CD is the deviations and exclusions, whatever things are deviated from what user asked for. So these things will go through in three stages. We are passing to the LLMs, the prompts, and the text extractor. So whatever the responses we receive from the LLM, that is actually concatenated and formatted in the offer summary step. So here we will get the final Excel sheet that has a SWB sheet separately, and panel, and then CDE that has the information from the LLM in a formatted way requested by the engineers. So now the first process here is what the user uploads a zip file. So when a user uploads a zip file, that contains three things, mainly the technical specification document, and then the SLD images in a PDF format. Then we have the metadata file. So this metadata file will have the information of the tender ID, to which project this tender ID is belonging to, and what is the revision of it, which plant does this belong to. So all these information will be there in metadata, which we actually process into another sheet called project ID, where we store these informations. So once it is actually put into the inbound folder, there is a S3 event notification getting triggered. So this will put the message into the SQSQ, which follows the first in, first out thing. So the messages are processed in the same order we receive it. After that, we have this data quality check Lambda, which will be further explained, and the end-to-end process will be explained by our co-author, Suhas.
Yeah, hey guys. So I'll be explaining the end-to-end process. So the first step, So the first step is data quality. So what we do in data quality is basically we extract the contents of the zip file, and if there's in the SLD, we extract the bounding box, and we also enhance that quality of that image. So we apply some basic pre-processing techniques like increasing the contrast, or detail enhance, or even zooming and zooming out, and playing with the aspect ratio in order to get the best results out of recognition, which is our OCR for the SLD. Yeah. So the second step, what we will be doing is the OCR extraction. So there are basically two documents which we will be using, which is the single line diagram and as well as the technical specification. So the what we do is we pass our single line diagram to our AWS recognition, and we pass our technical specification to our AWS extract. So the key reason why we chose extract is because the technical specification could contain a table, layout, etc. And with extract, it gives us that exact format of the output that we are looking for, so that we can pass it on to our LLM for further processing. And the reason why we chose recognition is because when it comes to single line diagrams, we found out that passing it to AWS recognition by calling it multiple times would enable us to get like the most content out of that SLD. So I'll explain to you what we are doing with the SLD as well as the technical specification. So these are like our OCR results. Basically, we have for the SLD, we have the text that we detected as well as the coordinates of those text. But as for the technical specification, we just have whatever we get from the Textract API, which is basically formatted as like whatever we get in the table, it is formatted as it is. So with the AWS recognition OCR that we received for a SLD, we use a rule-based engine to find out what components are present where in the SLD based on their ratings and their position. So as you can see in this image, we find out a lot of circuit breakers, CTs, which are the current transformers, voltage transformers, relays, meters, etc. So we use a rule-based engine and the OCR to find out the different positions and the coordinates for these items. So the next part, what we do is we have to pass our large context to our LLM. So there's the the problem with the LLM is that we can only pass 200k tokens because we have a large knowledge base which can contain up to 200 to 300 pages or even 1000 to 3000 pages. So what we have done is we have chunked our PDFs to get only 200k tokens, and we repeatedly parallelly call our LLM model, and we use that knowledge base and extract different prompts or key data points from our LLM. So after our collaboration with data engineers and the key people who are the end users of this project, we have found out like key data points, necessarily being the compliance standards, the safety standards that are actually mentioned, and the different components that are mentioned in our technical specification. And we have engineered our prompts in such a way that we get those answers and as well as the multiple references for those answers, so that user can basically just check where his answer is. He can cross verify his answer and also find the page numbers for those answers and can provide the best bid for his end. So the last step would be to generate the offer summary. Basically, after giving the answers and the annotated SLD that I just showed, we basically formulate this entire end-to-end solution into an Excel sheet, and we give that answer as the end result. So this is an example of how the output would look like. So answers marked in blue would be the ones that we get from our SLD. So we have identified different components, feeders, and its ratings. And answers marked in red would be the ones that we get from our technical specification. These could include the intelligence of the LLM as well as the prompting. Yeah. So the limitations for this would be just so we are majorly dependent on the OCR. So anything wrong in the OCR result would cause our LLM to misbehave. So these are some of the limitations. Yeah, so we are open to any questions. And so so what we are doing is we generate this. So all they have to do is they have to just upload the file, and it generates results in about like 5 to 10 minutes. Instead of them going over that document, searching for each of those answers, we just generate it in 5 to 10 minutes, and all they can do is just cross verify and then upload it to their end user.
What prompts usually you used to give, because it's a bit to bit, it will vary, no?
Yeah,
Components will vary, costs will vary.
cost will vary. Yep.
And what is the maximum thing you can go? What is the minimum thing you can go? How you will decide that was decided by the LLM, or you are prompting the things?
We are prompting. So we have collaborated with our tender engineers, and we have we know what needs to be taken out from our technical specification. So it generates a summary of the technical specification so that they can just cross verify, and if they have anything to update, they can update.
So human intervention is required in the loop.
No, it is not required in the loop. They can change it if they want, or they can directly upload the result. Yeah, this is just for them to ease the process.
It's okay. Thank you.
Yeah.
Hello. I I have a question.
Yeah, sure.
So this SLD is a image, right?
Yeah, it is an image.
So when I used GPT-4o, like it couldn't recognize the layout of an image, right?
Okay.
It could only caption the image. How good was AWS recognition? Um, how good was it? How could you understand the layout of the image? Was it necessary in your use case, or?
Yeah, so for us, using an OCR plus our own rule-based engine was more necessary, since we could identify the different panels in the SLD or different components. When we did try it with GPT and other models, but it didn't really give that good of a result. Yeah. So
Really a very tough job to find out whether, as a sales engineer or a pre-sales engineer, to find out if I missed any important point which has been requested by the potential customer. So
correct.
have you identified any way that it is totally foolproof, and at least I quantify that something has really got missed, because this is very important and very tedious to go through if it is a 200-page document and really something misses out.
Yeah, there will be always something that would be missed out. We can't guarantee 100% of the result. That's why I'm telling you, we are we have tested this with our end users already. It's giving around 80 to 85% of accuracy. So there would be human intervention required by the end user only to clarify. So what we are planning to do is basically make this into a better model by reprompting our answers and then checking if it is correct again. So in order to get the full accuracy.
So my final question will be, how much time saving you are getting with respect to a complete manual task to this application?
So a manual task would take around, depends on the technical specification and the single line diagram. So according to our end users, it would take around 30 to 45 minutes for them to actually get the entire offer summary. But we are doing it in 5 minutes on an average, and yeah, that's it.
I have a question.
Yeah.
Hello, I'm Anirudh from UI.
Okay.
So I wanted to ask you, is it also a possibility where other side of the table, where you need to draft an RFP in order to get responses from the vendors, right?
Okay.
So is it where even that is a very tedious task where you have to mention all the TQs and how to create the graphs and all of this part, right? What is needed, what is not needed. So have you tried that part where entire RFP document has been created?
Yeah, so an entire technical specification document we do provide. We chunk it based on our LLM, and then we try to generate the best results from each page. So we also have done the RAG solution where we do the context-aware chunking. So this pre-generated, we have a static prompt which we have generated based on our collaboration with our tender engineers, so that we get the best summary out of it. So that's how we're getting the end.
But in order to create the proposal or so, right? some human intervention is still required, right?
Yep,
Like to
yeah.
explain what is the real ask. So you
So for the
How do you
initial
capture?
thing, we need support from the tender engineers. So if you see the deviation sheet, some 2 3 slides back it was, we have this options where which if you see here, the degree of protection. You have IP 30, 31, 32. The second, yeah. If you see, these are the things they expect for this particular plant. For this particular plant, they need only IP 31, 32 or the IP3 series. So after giving this, we make the prompts in the same way that we receive only these information. So we will get at most in the initial we need the knowledge because we doesn't know about like what we want from what they are expecting. So after this we will get, if you see that top row, you have lot of references like it is a deviation and the reference document. Also they have to select which is very much applicable for that because there will be same line repeated or same reference is there in multiple pages.
Yeah.
So we can take it from there the tender engineers has to decide.
Yeah, one last question. Okay, have you embedded into any other tool where bid management process or vendor management tool? Anything you using there? Like keeping it like standalone application, it is right.
Yeah, it is a standalone.
Standalone.
Amazing.
Hi.
Thank you. So,
Just
more
one,
question?
just one last question.
Yeah, sure. Go ahead.
Hi. Would just like to understand so in line diagrams, how are you contextualizing after the output from the line diagrams, which is coming from text track and recognition? How are you contextualizing it for the next steps to get this kind of an output?
So what we have is this sheet called panel. So basically, there are different. One second. Yeah. So there are. So what the end user basically wants, which are our tender engineers, in order to bid, is the different panels of a switchgear. So basically, we split those into different feeders, or we can say circuit breaker. We consider that as a separate panel, and we group the components. So there are different rows which asks what is the rated voltage of the circuit breaker. Sorry, the current of the circuit breaker, and also the rated voltage of the switchgear, or it could be the current bus bar current, things like that. So we are using our rule based engine and the OCR to get those ratings into our final output. Okay, no, that we don't have. That the tender engineer has to himself do.
It will supplement it, this
Yeah.
thing, for making the final bidding.
Yes, I'll just.
Okay. There's a lot of deviations will be there. Now costs will be more fluctuated, and the materials, if there is any delay in the things, you will be having some factor of safety and other things.
Yeah, that is all given in the technical specification from which we infer.
Okay.
Yeah.
Yeah. Thank you,
One
Suhas.
question.
Okay. One last question we can
So
take.
when you change the image to text, do you have any validations that you do? Like, let's say your diagram was something and your recognition.
Okay.
I think you are using AWS recognition. Right?
True.
And what if there are some things that are missed? Like, how do you validate this?
So with our experimentation which we did initially, we used to mask each and every word that was detected, and we used to use our LLM. We used to use our LLM to actually check if those words were correct, and on doing so with that experimentation, we found out that it is actually giving an accuracy of 90%. For now, there is no validation that we are doing, but yeah, that's it.
So from AWS recognition, do you get a JSON? Like, do you give
Yep.
a structured, like this JSON? Do I want the output?
Yeah, we do get a JSON. So, but there is a word limit in recognition which only detects 100 words per call. So you mask your words from your previous call, and then you pass the same image.
Okay.
So with that, you get the best out of it.
Multiple calls you.
Yep. Yeah.
Thank you.